everyone. Welcome to Laser Tech Tuesdays at 2. I'm Jake Cottrell, and I'm the Marcom Manager here at LTI. Every Tuesday around 2 p.m. Mountain Time, we go live for about 15 minutes, and we discuss solutions in traffic safety or professional measurement. Today, we will be talking about a solution in industrial sensors, so we have a treat today. Grab a cup of coffee and join us. I want to introduce our product manager for the industrial sensors. This is Clint. Clint, could you give us your full name, title, and how long you've been with LTI?
Sure. My name is Clint Cowan. I'm product manager for the industrial sensor line, and I've been at LTI about 6.5 years.
So today you're going to take us through, it's going to be a little bit different rather than a get-to-know-you kind of thing. You're going to show us a live demonstration that we have that people can actually go and see right now on the internet.
Sure.
But I was hoping you could talk us through what we're doing with this demonstration.
Sure. Absolutely. Should I bring it up now and share the screen?
Yes, please do.
Okay. Allow me to do that. Hopefully everyone can see the screen.
I can see it.
Okay. I'm going to enlarge the picture of the demonstration. And this is live. There may be a 2 or 3 second lag just due to the internet itself, but otherwise this is actually happening. We have this demonstration set up and we're running it 24/7 at LTI. This is a small scale version of our application in a lot of liquid applications, industrial applications, where we have a variety of customers wanting to measure liquid levels in all types of vessels and all types of industries and applications. In this particular case, we're mimicking a water, wastewater type application on a small scale where we're measuring the water level in tank 1 as it's going up and down. And you can see we're pumping water from one tank to the other. As one tank goes down, the opposite tank goes up. It will reach a certain spot in the tank. It will stop pumping and it will reverse. And what's controlling or what's feeding in the primary information are the 2 sensors at the top of each tank. That's our product. That's the S330 that's measuring the water levels. And when it reaches a certain level, it sends that information to the PLC down below, and the PLC turns off one pump, turns on the other pump. And a PLC is a common instrument used in a wide variety of industrial settings in all types of applications. So we fit seamlessly into a PLC and can operate within that environment, supplying the critical information on water levels that allow the PLC then to do what it's programmed to do. In this case, start and stop pumps. So I'm going to minimize this window back, and you'll see to the right, we have a graphic of what the tank level in tank 1 is. And it's going down right now. And shortly, when it hits a certain level that will be coming up soon, it will stop and then reverse. So the water should stop momentarily and then start pumping into tank 1. Okay, there it goes. So when it turned orange, it means both pumps are stopped. Water is not being pumped one way or the other. Then it will reverse and start back up, and you see it there as it turns blue. Tank 1 will start filling back up. And our gauge to the right of that, the one that looks like a clock, it's a round gauge, that's actually giving the water level in tank 1. And this is measured in feet. So we're measuring the distance in tank number 1 in feet. And where we have the red, that's critical. It should be operating in that area. In the green, that should be operating. And when it hits the high level, which is near 2 feet, it will stop and then reverse and go back the other way. And then the line, the graphic we have below, is what our performance in tank 1 has been in terms of level over the last 2 hours. So we have a time frame you can go back and look. And what you're seeing is what we expect to see, a very consistent peak and valley in that measurement, which means the sensor is working correctly, the PLC is doing its job. When it peaks at 2 feet, it turns off, reverses the pump, it gets down to about 6 inches from the bottom, and then stops and reverses it again. So therefore, you have a very consistent graphic for the last 2 hours. And we just chose 2 hours as a arbitrary time frame. We could go back months and if we wanted to. So basically, this is demonstrating several things about our sensor. One is the ability to track water levels accurately and feed information to the PLC. Number two, it's also showing that if you'll observe in tank 1, you see the water levels that's rising is very turbulent on top. I'll increase the screen so you can actually see that a little bit better. See right here, the water's really bouncing around up and down. That's a very dynamic situation. Not all sensors can track water levels when it becomes that dynamic, and yet we're able to do that. So that's also another demonstration, small scale. When you upscale this into a large tank, that water becomes very dynamic. So if we can measure it here, we can handle a lot of different applications and conditions of water other sensors just don't do. They will go offline until that water calms down. We're able to still track it. That same ability of the sensor to do that here will allow us to do it measuring rivers and streams and things like that, where the water can be very dynamic and we can still measure it accurately. Another thing that we're doing is, believe it or not, one of the toughest materials to measure as a liquid is clear water, especially for lasers. And that's the reason why the water's basically clear here. It's our worst case scenario, and we're able to do that. The more opaque the water gets, the more dark, cloudy it gets, the easier it is for the laser to track it. But when it's still clear, we can track it. So we can handle all different liquid conditions, be it clear, calm, turbulent, opaque, anything in between. So this is a demonstration that we actually built for trade shows. And since COVID has stopped us from going to trade shows, we decided to put this thing out and actually have it up on the internet running 24/7. So we actually have a virtual demo that anybody can come visit at any time, and just by visiting this website.
So, Clint, what industries do we currently have this sensor in?
We have it in a variety of water, wastewater applications throughout North America, and we're starting to penetrate some markets in Asia and South America. We also have some people working with the sensor and experimenting with it, measuring rivers and streams. We have this in North America, and we also have it in Asia. And we have a few chemical applications where people that are manufacturing chemicals are measuring the chemicals in large vats. And we haven't had any food and beverage applications yet, but we expect to pick up some of those as well.
So
our sensor takes advantage of a real trend in the industry, and we can talk about everything from the Army Corps of Engineers to water, wastewater, and other applications where traditionally they've been more involved with pressure sensors, a sensor that is placed down at the bottom of a vessel or a river that uses the water pressure to determine the level. And what we're hearing more and more, especially in situations where the water is dirty, it contains things like mollusks and snails and growth like out in the ocean, that these sensors need to be maintained. They need to be pulled out of their environment and cleaned on a regular basis in order to continue to work. And sometimes that could be daily or weekly as far as maintenance goes. Where our sensor is a non-contact sensor, we mount it at the top of the vessel, and there's really no limitation. It can go up to 50 meters above the water level and still measure it accurately in many cases. So you can mount it where it's convenient for you to mount it, get to it, and it doesn't require a lot of maintenance because it's not making contact with a nasty environment that may be down below. So the lack of maintenance is a big plus for a lot of our customers. Those are some of the first customers that come to us when they're experiencing high maintenance costs with other sensors, and they want to reduce or eliminate those costs, and they're looking at a non-contact sensor as the best way to get there. And we have some advantages over other non-contact technologies, such as radar or ultrasonics, and that can be looking down a stilling pipe, mounted next to a wall, looking through narrower spaces, going longer distances. And so a lot of people that run into those issues when they try and use a ultrasonic sensor, for example, we don't see that same issue, and we can perform in that environment.
So, Clint, if anyone wants to visit this on the internet, what is the website?
It's called measuringthefuture.com/SCN/S330-demo/.
Okay.
You can also go to our website, our microsite, or our corporate site, and we have links to the live demo there as well.
This is pretty clever. Have you seen a lot of good results when you've presented this to people?
Yes, they're generally very impressed with the reliability, the ability of the laser to measure clear water, turbulent water, and to do it without any issues for weeks and months on end.
Well, thank you, Clint. I appreciate you showing us your demonstration today. Are there any questions that people frequently ask when you show this to them?
At trade shows, when we first started, they wanted to know what the technology was that was measuring the water, and we said laser. And some people weren't familiar with how lasers can do that. But we have some special algorithms and some other things that are patentable with our technology. We've been doing lasers for 35 years. So we've got some very advanced, intelligent lasers, and we can handle this easily. So that's one question we get. Another question we get is reliability. Can you measure under different conditions, such as if there are suspended solids in the liquid? Does that have any issue? And that's a question that's familiar from the ultrasonic and radar side, where what's called a dielectric current has to be factored in to measuring with those technologies. We don't have any limitations regarding dielectric current or properties of materials in the liquid because we're an optic technology. We're looking at the surface of the liquid, and that's all we care about. We don't care about what's in it, what its dielectric property is. It makes no difference to us as a technology for measuring. So we're actually a lot easier to set up because we don't have to factor those things into the equation.
That's pretty amazing. I think our laser sensors are pretty impressive. Is there anything else that you wanted to make sure people knew before we end our demonstration today?
I guess one of the things is that we've come across over and over again, whether it be wastewater, chemical processing, or some of the other technologies, is typically being a newer technology, there's some skepticism surrounding it. And they use it in one application, and over again, we've heard, wow, this thing worked a lot better than we thought it did. So now we're thinking about moving it over in this application, or maybe this one over here. And so it's overcoming that initial, apprehension to use a new technology. But once they see it perform, then they think of other uses for it as well. So we're excited when we hear that over and over again from customers because we're learning as fast as they are about all the different ways we can perform in this industry, which is absolutely huge. Liquid level measurement encompasses so many major industries and applications. It can be overwhelming at times.
But that's also the exciting part about your particular division is that you get to problem solve with our customers.
Yes.
And
And it's great. They all have unique challenges at some point. They all have a problem measuring some type of liquid in a certain application. And a lot of times we can help and we can assist them. And that's always a good feeling when you're able to do something they haven't been able to do before.
right, which is, I think that's part of the excitement with working with industrial sensors is that it's not an out-of-the-box solution, which could make some people a little nervous, but at the same time, we give them plenty of support so we can solve whatever quirky problem they may come up with.
Yeah.
Well, thank you so much for joining me today, Clint. I want to thank everyone for joining us live today. If you want to be alerted about upcoming Tuesday at 2 events, you can click the like for our page and make sure that you're following us. And if you're watching the replay on YouTube, you can subscribe to our channel and click the notification bell so that you'll be notified when we have new videos up. Please join us again next week on Tuesday, again at 2 p.m. Mountain Time. Until then, keep measuring safely and working smart. Thank you.
Bye.